Hey everyone, I'm Michael Hartigan of Oneskyastrology. This video is going to be about axial precession and the precession of the equinox. I get asked a lot about both of these things, and they're often conflated with each other, but axial precession is an astronomical term, and axial, meaning relating to the axis, and precession, the opposite of procession, to move forward, means to move backward. So, the best way to think about this is with the model of a gyroscope. And if a gyroscope is rotating clockwise, then its axis will wobble counterclockwise. That's the axial precession of a gyroscope. When it comes to the axial precession of the Earth, as the Earth rotates, moving around the Sun, the axis of the Earth wobbles in the opposite direction. One of the things this means is that Polaris is not always going to be the pole star. For example, Vega and some of the stars in Draco are, over the course of what scientists think is about 26,000 years, that northern orientation will actually make a little circle and it'll move. So the pole star isn't really a fixed thing. That's one of the things axial precession implies. The precession of the equinox is an astrological term, and this is a little bit more difficult to explain, so I want to show everybody visually. Alright, so here's a sunrise that's about to happen. We've got Virgo poking its head up over the horizon. Now, if you were watching this sunrise, you would say that the sun was going to rise in Virgo, in early Virgo. And there it is. So you would observe that and say that the sun was in the constellation of Virgo. And every year on the March equinox, which is the vernal equinox in the northern hemisphere and the autumnal equinox in the southern hemisphere, every year for thousands of years before thousands of years, people have observed the sunrise on the autumnal or the vernal equinox. I'll call it the vernal equinox because I'm in the northern hemisphere. So, around 4000 BC, that sun was rising in Taurus. And if you observed the sunrise on the vernal equinox in ancient Egypt, you would see it rising in Taurus the bull. And if you observed it rising in about the year 2000 BC, you would see it rising in Aries the ram. If you observed it rising 150 years BC, you would see that it was just starting to rise in Pisces. So we're moving backwards through the zodiac, hence precession. And every 72 years, that point of the sunrise drifts 1 degree relative to the fixed stars. In the year 2600, roundabout, the sun will rise in the constellation of Aquarius, and we will have finally entered the age of Aquarius. And that is the precession of the equinox. So, how are they related? Axial precession and the precession of the equinox. Well, that's kind of interesting because some people say that axial precession is the cause of the precession of the equinox. Isaac Newton postulated that it was due to the axial wobble of the Earth as it moved through space, that that wobble, actually, one rotation of that wobble took about 26,000 years. It was a very slow wobble. And as that wobble wobbled, the constellations would move, seemingly, in reference to the point that the sun rose. Well, again, since the time of Isaac Newton, people have been working on the equations to try to understand how that axial wobble created the precession of the equinox. And they've added and subtracted variables like torque, and they've been working on this for, that's since the mid-second millennium, and nobody's been able to solve that to scientific satisfaction. They're still trying to balance those equations, and they add factors like, well, the Earth isn't a sphere; it's 27 miles wider than it is tall, and they can't get that to make sense. Although that is the going theory, because Isaac Newton was a handsome man. But in all seriousness, another theory about why the equinox precedes is that the sun, like most stars, actually, that we observe, most stars are binary star systems, which means there's a relationship between two stars where they're in gravitational relationship to each other. And one possible cause for axial precession would be that our sun was a binary star system. And in fact, people who know a lot about this say that if our sun wasn't a binary star system, that would be weird. Because it seems that the formation of stars happens in pairs and triplets. For a star to be just a solo star, just hanging out in space without a partner, would actually be in the minority. So people have been looking for the sun's sister star for a long time. There's a binary research institute that I'll leave a link to below, and there's some really interesting research by people like Walter Crittenden and Dr. William Brown of Colorado State University that indicates that Sirius is a likely candidate. And you can think of that in terms of if you were holding hands with someone and you were both spinning around, well, the room would spin, but you would see each other staying the same. And if the sun and Sirius were in orbit with each other, then that would be one cause for the heavens' rotation. So they've had telescopes trained on Sirius for the last 20 years and more, and it hasn't moved a bit. It's as if there is a very unusual relationship between the sun and Sirius, but we don't know yet. We're not sure. There's a great movie about it called The Great Year. The Great Year. I'll leave a link to that, and totally advise you check that movie out. It's on YouTube. It's been published by the Binary Research Society. That's Walter Crittenden's movie. So nobody's ever got the math of axial precession and the precession of the equinox to quite work out. Axial precession definitely happens, and the precession of the equinox definitely happens, but we don't have the math to relate them to scientific satisfaction. I think that's about all I want to say for this video. That's axial precession, and that's the precession of the equinox, and That's why it's important in astrology and astronomy. All right, thanks for watching. See you next time.